Hello guys, how are you? I hope you will be fine. Welcome to my channel. Please subscribe and like this video. This video is related approximate searches. This video is very interesting. Let's start this video. We are going to talk about searches with exact match, metric spaces, approximate searches, edit distance, example, pivoting, indexing, future issues, requirements to approx searches, PostgreSQL, C language, SQL language, PL, PG, SQL language. Exact match. Select star from customers where name is equal to in ratio. Result name in Shrizo address 2 Red Street Town Ottawa. There is a match. Exact search. When can I use it? It makes sense to use an exact search when we presume that our result is inside our database where name is equal to Enrico, exact search, match and null. Other kind of search: images search, sound search, economic search, DNA search. Other kind of search: similarity searches. Some examples: text retrieval, image searches, sound searches. Other similarity searches. In the exact searches, we think our dataset as a set of rows and we can make searches inside it. When we make a similarity search, we have to think our dataset as a set of objects. The query is an object to that can belong or not belong to the dataset. The similarity search is the search of objects that belong to the dataset and that are closer to the query object. Added distance or Levenshtein distance. The added distance between two strings is given by the minimum number of operations needed to transform one string into the other, where an operation is an insertion, deletion, or substitution of a single character. For example, the distance between kitten and sitting is 3. Kitten, sitten, substitution of S for K. Sitten, sitting, substitution of I for E. Sitting, sitting, insert G at the end. Now we can compare strings. Every kind of object starting from its features. Every object has features. We find an object that has the smallest distance from our query. Added distance, query image, query results, image database, feature extraction, feature vectors. Some problems: objects can have many dimensions, typical 50 to 60 dimensions, one dimension for each feature, for example 3 for RGB images, and so on. We can spend much time to calculate the added distance. Metric spaces. A metric space is a set S with a global distance function, the metric d, so that for every 2 points x, y in S returns the distance between them as a non-negative real number d, x and y. The distance function d, x, y must be non-negative, d, x, y greater than is equal to 0, strictly positive, dxy is equal to 0 if x is equal to y, symmetric, dxy is equal to dyx, have to satisfy the triangle inequality. Dxz less than is equal to dxy plus DYZ. Database objects are seen as points in a matrix space. Query point can belong to the data set. Query point cannot belong to the dataset. Dataset versus points. Objects and queries are seen as points in a multi-dimensional matrix space. Matrix spaces searches nearest neighbor search of the object more close to the query point. K nearest neighbor search of the k objects more close to the query point. Range query search of objects that are inside the circle with a given radius r and center in query point q. Nearest neighbor. The point P1 is the nearest neighbor for the query point Q. K nearest neighbor. An example: select parola distance parola contorno from parole order by 2 limit 5 Quintero Terry Comparesa Donna Scomparso Nono Volto Quattro Controno Nono 4 Compressa 5 edit distance Donna 5 edit distance Volto 5 edit distance Quattro 5 edit distance. Range query. Points P1, P8, PD are inside the circle. I hope you would like this video. Thanks for watching this video. Allah Hafiz.